Okay, we're going to prove congruent triangles today, I guess. Looks like there was maybe one above this, 23, that didn't get in the picture.
We did that one in class.
Okay. All right, 24. We supposed to do a 2-column proof?
Yeah, 2 columns.
Okay. Statement, reason. Statement 1. What should statement 1 say?
Line LI is congruent to line NI, and line GI is congruent to line EI, as the reasons given.
Okay. Second one. Should make these congruent. Not quite the same as equal. Okay. Our goal is to prove that this triangle is congruent to that triangle.
Yeah.
So what do we have so far? We're looking for equal sides, equal angles.
Yeah. Equal sides.
We have 2 equal sides now. We have that BI is equal to that GI. And for this triangle here, this side, LI, is equal to NI. That's what those first two statements say. So we have side, side. So is there an angle that we can tell is common to both and equal?
LIN?
Yes. And why? Angle LIN. What's the statement? Equals what?
90 degrees?
No? Angle LIN equals angle LIN.
Oh, it's reflexive.
Reflexive property. Now, whether they absolutely have to have that in there or not, I'm not sure. But in a 2-column proof, I would say yes. You probably do have to put that in. And so now, what's the third statement?
LIG is congruent to NIB, triangle. LIG is congruent to triangle NIB.
And why? You don't have too many choices. You got side, side, side. You got side, angle, side. You got angle, angle, side. And you got angle, side, angle.
Is it side, angle, side?
Yeah. In other words, you do it in order. We've got that side. We've got that angle. And we got that side.
All right.
So you can see that it's side, angle, side. So side, angle, side theory for congruence. Okay, and that's all we were supposed to prove. So let's have a look at this. First statement.
Line HW is congruent to line MW. Line AH is congruent to line AM.
Given, okay. We're trying to prove this triangle is congruent to that triangle.
You can say WA is congruent to WA. And that's reflexive.
These are pretty easy, actually. I expected something a little harder. What's the reason?
Angle side?
What's that?
Is it angle side angle? Or
What angles do you, what two angles do you know?
There's no angles. Side, side, side then.
Side, side, side.
Oh,
Do they let you get away with just that?
yeah.
Good. They should. In other words, you shouldn't have to quote the exact wording of the theorem.
Okay.
Okay. And this one, hold on, I need a little more room. Okay. I know you know what goes in line 1, so that's the given. What's next?
EML congruent to LMA.
Okay.
If you have to elaborate and say EML is 90 degrees, you can say LMA is congruent to.
Well, let's go through a formal proof here. I think a formal proof is angle BML equals 90 degrees.
Definition of a right angle.
Definition of perpendicular. Statement 3 is, in fact, there's a theorem that when two lines are perpendicular to one another, it creates.
All angles.
So we don't need a statement 3. We can just say angle LMA is also equal to 90 degrees and use the theorem regarding perpendicular lines. You know which theorem I'm talking about, don't you?
Yeah, I think that's just called the right angle theorem.
Oh, good. Right angle theorem. Okay. Now, this is the one where you might need a statement. Let me think for a moment.
You should just say that LM equals LM.
At this point, we only have one line and one angle that are equal to one another.
Technically, you have two lines because
Oh, you're right.
bisex.
You're right.
Right.
Because, in other words, you can say BM equals MA.
Mm-hmm.
Also,
that it's bisected out.
right. Well, it also says, no. Notice what LM bisects, not BA.
But it bisects and it cuts it in half, and this side we cut in half.
It bisects this angle. In other words, this statement right there means that BLM is equal to MLA. Angle BLM equals angle MLA. Definition bisects. Now what do we have in the way of congruent triangles? In other words, you almost always, unless it's a right triangle, you need 3 pieces of information. So we have an angle. That angle is equal to that angle, and this angle is equal to this angle. Something else we need.
If that angle's bisected, wouldn't you have 2 equal angles? And that way you'd have ASA.
Right. The statement that we need in the 2-column proof is segment LM equals segment LM.
Okay.
Again, reflexive. All 3 of these questions required the reflexive property, which is probably the most annoying one that there is. Don't you agree? Having to state that? Yeah. And now finally, but all of the 2-column proofs I've seen, especially regarding congruent triangles, because if you're going to use, one of the congruent proofs, then you need 3 pieces. And at the moment, we only have 2. We only have this angle equals that angle, and that angle equals that angle. So now that we say LM is congruent to LM, now we can say the 2 triangles are congruent based on what?
ASA.
Yeah. I guess there's a reason they have 2. I thought about that, and I'm still not sure why they have an ASA and AAS. Seems to me like they're the same thing, because when you have 2 angles, you have 3 angles. So all of them are really angle, 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 side. And it doesn't matter which side. If you know you have 3 angles equal, then you know they're at least similar. And no, now I know the difference. Just occurred to me. Let me explain to you why. I just realized it. Hold on. There is a difference. In other words, if I draw 2 similar triangles, let me redraw this one. Those 2 triangles are similar because we have angle, angle equals angle, angle. But I can't just have one side over here equal one side over here. What if this side were 10 and this side is 10? In other words, then I would have angle, angle, side. No, but I wouldn't have angle, angle, side. In other words, this one is angle, angle, side, but this one is angle, side, angle. So you would not have congruency. Even though, in other words, what I was thinking before is that if you have angle, 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 side, that's always going to be congruent to angle, 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 and it doesn't matter where you put the S. The S could go there, the S could go there, the S could go at the end. But I was wrong. And this is the perfect example of it. In other words, you can't have angle, side, angle being congruent with angle, angle, side. That doesn't work. And that's why they distinguish between them. That's why they have a different angle, side, angle, and angle, angle, side. They're not exactly the same. Okay, cool. I explained it to myself, but that's okay. Helps for me to understand it. All right, I have somebody else in 30 minutes that gave me these 3.
Oh yeah, that's the worksheet. Oh, is that the same ones?
It is the same one, isn't it? Exactly. I was thinking it was different. Not. Okay. Well, I don't need that one then. I was thinking I had some more problems to give to
Are
you.
you sure? Because that looks like my picture, because I only took a picture of those three.
What's that?
That looks like my picture, because I only took a picture of those three.
Oh. I wonder if you sent it to me twice, perhaps, or maybe I copied it twice. So both of those were from you, I think. Although I don't know, I have 3 geometry students today, and I think they're all from Chatfield. So one of them could be. Although, like you said, of course, maybe the other student only copied the 3 problems also.
Yeah. She also gave us another one today.
Okay, is it something you can describe?
Yeah, I can just, like, if you want, I can just send a picture real quick.
All right, do that. Send it to my email. While you're sending it, let me send out this thing. All right. You send it?
Mm-hmm.
We could probably tell the network speed based on how many seconds it takes to get here. Although maybe not. That might be a factor of Google Mail also.
I think it's a factor of Google.
Yeah, no, I got it. I thought I got this from another student too. Yeah, I had this thing at the top.
You might have, I don't know.
Yeah, I did, because I've seen these problems. I was reviewing them, and it had at the top, every statement has a reason. Okay, let's do this. Rather than writing out a 2-column proof, you can probably tell me how to do all 3 of these by voice.
Yeah.
Which one are we going to use here? Got that's congruent to that, and we got that angle is congruent to that angle.
Mm-hmm.
So which congruency theorem are we going to use?
Angle side angle.
2 angles? We only got 1 angle. We got this angle equals this angle.
We got
This side equals this side. The one in the middle is common to both.
Angle.
The one
That's why that angle equals that angle.
Which is this angle equals that angle is the given.
Okay.
And this side equals that side is the given. What other side is in common to both triangles?
The reflexive angle. So
exactly. Every problem seems to have one of those. So which congruency theorem?
SAS. Side angle side.
Those 2 lines are parallel, top one and bottom one. K is the midpoint of that. So explain to me why these 2 triangles are congruent. Which lines are equal?
EK and KI are
No, if K is the midpoint of YS, then which two lines are congruent?
Oh. YK and KS.
Okay, that's a start. Which angles are congruent?
YKI and KS.
Well, you mean K and the other side of that? Oh, that's
Yeah.
outside the triangle. But how about this
Outside.
one? How about this
Yeah.
one and this one?
Yeah, those are vertical angles.
Okay. How about, is that equal to anything?
That's E is equal to I.
And S is equal to Y also, because of parallelness.
Mm-hmm.
So you got angle, angle. We actually have angle, angle, angle. But we've got angle, angle, side.
Mm-hmm.
So it's AAS.
Yeah.
And let's see if we can do this one real quick. I do have a 4 o'clock. I better go, otherwise I'll be late for it.
All right, sounds good. Thank you very much.
You're welcome. Seems like you understand it pretty good.
Yeah, I just wanted to go over it since we have a quiz tomorrow.
Okay. I'll talk to you next Monday, Cole. Bye-bye.
All right, thank you.